Okay, the last thing we're going to do here is solve some trig equations. This comes up in a bigger way, I believe, later, but setting the premise for this is really good here. We're going to find all angles that satisfy this equation. Okay, now, just to understand what's being said here, I've put the line y equals the square root of 3 over 2 on this graph. And you can see that it intersects the cosine graph in a number of places. It actually intersected infinitely many times. I would encourage you to make the connection between this and the unit circle and a number of things. We're gonna take a look at it. But basically, we want to find any angle that makes this true. So what I'm going to do here, and what would probably be the easiest thing, is that you should recognize this ratio at this point. Okay, and what we have to do is we have to say, look, here we're saying cosine of some angle is positive. Well, that only happens in the first quadrant or the fourth quadrant. And the cosine of this angle, whether it's here or it's all the way around here, is the square root of 3 over 2. So we can label our triangles in this way. Alright, this is my reference angle here. Alright, so you should recognize this at this point as the last side here is a 1. So this is a 30, 60, 90 triangle where my angle in here is pi over 6, or 30 degrees. Now, once I figure that out, that means this reference angle down here, even though this is negative, is also 30 degrees. You have to recognize this. Well, if this is pi over 6, then it must mean that this red angle that's all the way around here, sitting in the fourth quadrant, is 2 pi minus pi over 6, or 11 pi over 6. And what that tells us is that we actually have two solution sets here. If we have cosine of theta equals the square root of 3 over 2, well, theta could equal pi over 6, or theta could equal 11 pi over 6. Okay, now, what we see on our graph, and what's kind of cool here, I think, is if you make the connection, here is pi over 6, and here is 11 pi over 6. And what you'll see right here is kind of small to see, that's 2 pi. Alright, so this represents one period of cosine, and it also shows us that it begins to repeat after that period. See, this distance right here is 2 pi units, which is one period. From this pi over 6 to the next one here, which is actually 13 pi over 6, which is on the other side. Once you go around the unit circle, it's the beginning when you're going around again. That's where you have more of these solutions show up. So to deal with this, because out here somewhere, 2 pi later, there's going to be another solution and another solution. So one way that we deal with that is just to add a 2 pi k to the end of our solution here, which implies that where k is some integer, that if we add some multiple of 2 pi, or actually subtract, because we could go back 2 pi and end up on another solution, that this would take care of all the solutions. Same thing here. 11 pi over 6 needs to be taken care of, and 2 pi units away from that is going to be another solution. So writing that 2 pi k in there implies that there are more solutions, infinitely many solutions, but they're in those places. Okay, now with tangent, we got to be careful here. This one, this 1.72, is a little different than the last one that we did, because the last one we did, we had a nice ratio. Put this one on here just to show you how to use your calculator a little bit. Again, this is the line y equals 1.72. Notice it is hitting the tangent graph in a number of places. A little bit different than the last one is that from one solution to the next, instead of 2 pi units, it's just going to be pi units, because that's the period of tangent. But if I want to take tangent of theta, and that equals 1.72, in order to solve this, we have to use an inverse function of tangent. it gets rid of the tangent function and actually produces the angle that we're looking at for. Now, if we do that in this case, I'm going to pull up the calculator here. Hopefully it'll come up. There we go. Okay, and I turn it on here. What I can do, first off, the 1.72 is implied that we're in radians. So I want to make sure I'm in radian mode here. Okay, unless for some reason you were in degrees or that was 1.72 degrees that you wanted. Okay, and what I'm going to do is to find the angle, I will need to take the arc tangent or the inverse tangent of 1.72. Okay, now when I do that, I hit second arctangent of 1.72. And I hit enter. It's going to give me 1.04. So we're going to write that down. 1.04. Okay, now that is my first solution right here, 1.04. To get to my next solution, which is right here, I would have to add pi to it. And then the next one. So similar to what we did in the last one, we'll just add pi k to it. And that will take care of all my solutions for that problem.